Alright, so you can follow along in this video if you want, skip ahead, do whatever you want. So if you can kind of scroll ahead, you can see what slide we're on. So today we're going to explore slope-intercept form. I kind of talked about it in the previous unit. Basically, every linear function has a slope or a rate, especially in real applications we talk about rate, and then we have a starting point. Okay, that is really the definition of slope-intercept form. There is a rate and a starting point. So that's what we're going to discover today. So starting with the first slide is just basically picking, we have a point, we know that whatever that point is, it has to have an x value of 0. So let's just consider the equation y equals 2x plus 3. Drag a point on the graph to represent the output when the input is 0. Okay, so what would it be? So if we had an output, it would have to be 3, right? It would have to be 3, because if our input is 0, 2 times 0 right here is just 0, plus 3 is 3. So that's it, right? Let's look at this equation here, y equals 6x plus 3. What if we had an input of 0 here? Okay, so if our input is 0 here, what is that? 6 times 0, that's just 0 again, plus 3. Again, we're going to have plus 3. We had that last time, right? Another one, y equals negative rate, negative slope, negative 2x plus 3. And if we have an input of 0 there, negative 2 times 0, again it's 0. 0 plus 3 is the same thing. We're going to have an output of 3. All right. So what is a y-intercept? The y-intercept is where the graph crosses the y-axis. That's that vertical axis, which we label y. Okay. When it crosses it, it's called a y-intercept. Kind of sounds like intersection, but it's where the function crosses the y-axis. I like to call it the starting point. And why do I call it the starting point? Well, that's when the input is 0. That's our very starting point. So looking back at the taxi fare, when we have a 0-kilometer input, that's our starting point. We had like a 70 peso fare, right? So there's an example. So click on the blue point that reveals, okay, so then write the coordinates in the box below. So what was that? That was at 0 and 3. Or sorry, 2. Okay, that's for this one here, yeah. You can share it with the class if you want. Okay, so next one, up to you if you want to do that. Let's see, let's adjust the slider for b. So y equals x plus b, and now we're not changing the slope. So if we go back to what it told us to do initially was mx plus b. What we were doing is we were changing the m. Now we're going to change the b. Okay, oops, sorry, I went a little bit too far. Okay, how far did I go? Yeah. So I want to change b to 2. Okay. So there it is. What did we notice there? When I changed b to 2, so this would be y equals x plus 2. Look at where it crossed the y-axis. Let's change it to 3. What do we notice now? Did you see any difference in the slope, though? Because here we have slope, a rise of 1, a run of 1. So the slope is 2. Or sorry, 1, sorry. 4, 5. So look at what's happening here. B is the y-intercept, right? You can see that B is the y-intercept. So what connections do you see between B value in the equation and the location of the y-intercept? I would say B is, sorry, not capital B. B is the y-intercept. Yeah, for sure. You can share that with the class if you want. All right, and moving on. So y equals mx plus b. If we change m is 1. But let's see. B is 1 now. Look at, see that where it's crossing the y-intercept? It's at 1. What if I change m to like 2? Did it change the y-intercept? We still have 1 here. Let's go try something negative. Let's try that. Negative. Again, y-intercept is still the same. Y-intercept is 1. So that's what I'm noticing right now, right? What did you notice about the m value? M is the rate or the slope of the line. Okay? So m is the rate or the slope of the line. When we changed that, and we go back again, what happened? It was, so the slope of 0 is flat, slope of a half, then 1, then 1.5, 2, and so on and so forth. Okay, all the way up to really steep like that. And the same if we go with the negatives, right? So that's all it was changing. The y-intercept stayed the same. Okay, use what you've learned in the previous screens to describe at least 2 things you know about the graph here. Okay, well, if I say y equals mx plus b, well, what is m? M is equal to, in this case, 5, which is also the slope, right? And then b is negative 6, which is the starting point or the y-intercept, right? And that's when we had an x value of 0. 0 is the x value here. Okay, so that's really what we've noticed. I'm not going to share that because I think it'll give it to you. What is the slope of the line represented here? Which one of these represented the slope? Okay, so I want you to do this part on your own. You should be able to do that. What is the slope? Well, what is y equals mx plus b? Which one was the slope or the rate? Predict the y-intercept here. Okay, so when we have a y-intercept, first of all, we know that we've already discussed which one of these is the y-intercept. But remember, the x value would be 0, right? So I want you to sketch your prediction. So what does the graph look like? Really, we only need a couple points. So we could start with the starting point. What is the b value? Where is that? Okay, so if I know that my starting point is, let's see, what is it going to be? Well, somewhere here it's at 2, I believe, right? And then what's the rate? So the rate was 3. So if I go up 3 and then over 1, so I could go like 1, 2, 3, and then over 1, that could give me another point, and I could make that line from there, right? So I could go like something like this and extend that like that, right? So it looks something like that. Let's have a look at the next one. Y equals 3x plus 2. Okay, so we can put it in here. Y equals 3x plus 2. You can type this in. Does that match with our graph? You can go back and look at it. Does that work? We can check, right? This is actually a really cool tool that you can use to check your answers in the future when you're graphing. So if you just type up Desmos grapher, and then it gives you this function you can type in along the side. You can put the equation there. And finally, what do you think we call this, why we call this slope intercept form? Think about that. Why do we call it slope intercept form? This y equals mx plus b. Why do we call it that? Alright, so this summarizes things, and you should be able to have enough information to move on. Hope it was helpful.